What's going on, guys? Let's look at this problem right here. Here this question is asking to find out whether these given signals are periodic or not. And whenever you see a signal without phi, that is not periodic. Now we can prove this one. Now this cos function can be written as a cos omega naught n plus phi. Okay, from this pattern you know that omega naught is equal to 2, right? That's the one we want. Omega naught is equal to 2 because we are going to use this equation. M over n is equal to omega naught over 2 phi. Here we have to calculate n, and that n has to be an irrational number in order to get a periodic signal. Now let's see whether we get that one. If you rearrange this one in terms of n, we are going to have n is equal to this. Okay, if we put n in the numerator here, we are going to multiply this 2 phi, and omega naught is going to be in the denominator, then whole thing multiplied by m. 2 phi divided by omega naught. We found out omega naught is equal to 2, so 2 phi divided by 2, that's going to be phi, times m, that's going to be phi m. And this phi is not an irrational number, so this is not periodic. Not periodic. So this is the proof. Like whenever you see a cos function without phi, you can directly say this is not periodic. And also exponential function, same as that. Like whenever you see exponential function without phi, you can say that's not periodic. And if you look at this one, this is also without phi, this is n. So this is also not periodic. So we can directly say that periodic, not periodic. Okay, now let's look at this one here. Here we have sine 6 phi over 7n plus 1. We can always use this equation. N is equal to 2 phi over omega naught m. Let's use this one right here. 2 phi over omega naught times m. And this is going to be what? Omega naught is 6 phi over 7. This is our omega value. So 2 phi divided by 6 phi divided by 7 times m. Finally, 5 cancels. We will get 7 times 2, 14. 14 divided by 6. That's going to be 7 over 3. Now we have to see what's going to be the smallest number that can make this one an integer. So if you put m is equal to 3, this is going to become 7, right? So 7, therefore this is periodic. Now let's look at the last one. Here we have cos 0.15 n. 0.1 is the omega naught value, so we are going to have n is equal to 2 phi divided by 0.15 times m. 5 cancels, we will end up with 20 m. And what is the smallest value that can make this one an integer? M is equal to 1, right? So finally we will get n is equal to 20. So this is periodic. And that's how we decide whether a given signal is periodic or not periodic. I hope this helps. Thanks for watching.